Mr. Reese here. Thanks for joining us today. We are going to learn about factoring the sum and difference of perfect cubes, which is a little different than the difference of two squares. You might remember problems like this, like factoring x squared minus 9. The rule for this is when it's the difference of two squares, you get different signs here. So x times x, y times y. And if you were foiling this, the middle terms would cancel out. That's why there's not a middle term there. So if I was factoring x squared minus 9, I think perfect square, x times x. 9 is 3 times 3, positive, negative, done. Really easy. By the way, you can't factor the sum of two squares. However, with cubes, you can. You can do the sum of two cubes or the difference. And my memory device is this. By the way, I think most teachers would have these in a textbook and they'd say, memorize these formulas. They're kind of intimidating. I'm going to give you a process and a memory device that'll help. So when you think of a cube, picture like a dice or a box that's in that shape. So a cube is that shape. And then as soon as you think of cube, I want you to think of like a bar of soap. Now, here's where you have to extend your imagination. I realize a bar of soap is more rectangular, kind of that shape, but you're going to think of this. So you're going to think of cube, picture that, and think of like a bar of soap in the shower. SOAP stands for same, opposite, always positive. And I'm going to point this out in the formula right now. So if you're doing the sum of two cubes, this is positive, so the first one's positive. It's the same sign as that. Then it's opposite of that, and then it's always positive. The last one's always positive. So here, it's negative, so the first one's the same, negative. Then you do the opposite sign, and this one's always positive. I always make my students in class like do a big chant. So I'm going to take you through it. You at home can do the same. Same, opposite, always positive. Same, opposite, always positive. Same, opposite, always positive. So chant that over and over, you'll never forget it. Same, opposite, always positive. Let's apply this to two examples so you can see how this works. We are first going to factor w cubed plus 125. So here's the process I want you to go through. So immediately you recognize it's a cube. By the way, you should know your perfect cube, but let me put them up here. These are the ones that you usually need to know. 1, 8, 27, 64, and 125. You can go higher, but really these are the cubes that show up the most in an Algebra 2 class. So 125 is on that list. So you should be able to realize, okay, 125, that is 5 cubed, or 5 times 5 times 5. W cubed, or any variable cube, will be itself 3 times. I want you to write those down. Write those 3 letters down and 3 numbers down, and then immediately get set up. You kind of have to know that it's always going to be a binomial and a trinomial. So 1, 2 parts binomial, 1, 2, 3 trinomial. So you set this up, and here's how it works. This one's smaller. This one's bigger. The bigger one is greedier. It wants more of the terms. So here's what you do. The smaller parenthesis only gets one of each of these. So I'll go W and 5. Because there's 3 of them, I can't divide it evenly. But then there's 2 left over, so those 2 go in the bigger parenthesis, and W times W is W squared. 5 times 5 is 25. Now there's this gap in the middle, but this is what this is telling you. X times Y, one of each of these multiplied together. And that's why if you write these down, you will see the W and the 5, and you'll put them together, and that would be 5W. If you don't write them down, you're staring at 125 and you don't see the 5. So actually by writing these down, that helps you get that. And then this is where SOAP kicks in. So again, when you're doing cube, picture the cube, think of a bar of soap. And I'll do this in green. It's the same sign, same, opposite, always positive. And we're done. That's factored. This will not factor anymore. It's part of a formula. Some students think they can factor this more, like 5 times 5, but you're not going to get that combination. So that is the answer. You're done. Let's do one more, a little more challenging. Let's see what you can do with this next example. So example 2, let's do 8x cubed minus something, minus 27. So we're going to do the same process. We need to first think, okay, what should I write down? What times what equals this? So at home, think of this to yourself. Okay, it should be because it's 8x cubed, it'll be 2x times 2x times 2x. Those three things multiplied together give 8x cubed. 27 is on this perfect cube list. That one you probably know. It's 3 times 3 times 3. And then once you do enough of these problems, you know, okay, when I factor this, it's going to be a binomial and a trinomial. So a small parenthesis and a larger one. So we're almost done. We just take one of these in the smaller parenthesis and one of these in the smaller parenthesis. The second one, remember, it's bigger, it's greedier, it wants more. So I'm doing 2x times 2x, which is 4x squared, and 3 times 3, which is 9. And then we just need that little combo in the middle, which is what this formula is trying to tell you. Basically, one of each of these. I call it the combo. So the combination, one of these times one of these. Now what's 2x times 3? 6x. So I write that down. And then I go back in and I fill in the signs. This is the easy part at this point, I think. Same, opposite, always positive. It was negative, so same, opposite, always positive. And we're done. So hopefully this will help you with your factoring of sum and difference of cubes. Thanks for joining us today.